Alright, we're going to make Newton's second law easy. So I have printed you the 3 types of questions that can come out. These are the only 3 questions you have for Newton's second law. You can't be asked, you can be asked almost nothing else besides these 3. Alright, and now you're going to see there's a lot of similarities that come up in all the questions. We almost always start with define Newton's second law. Alright, so that's the definition you need to know. What is the definition for Newton's second law? Can someone tell me? Yeah.
Acceleration is directly proportional to the net force and inversely proportional to the mass.
Alright, so that is half of the definition. The whole definition says when a net force acts on an object, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. Alright, Newton's second law. Alright, the force acts on an object. Alright, and this is where the acceleration direct proportional comes in. Alright, there's your definition for Newton's second law. Alright, the next question that comes up every time is a free body diagram. Alright, what's required for a free body diagram? How do we start a free body diagram? Dot. Alright, it has a dot. Alright, and if it's on a surface, we will have our Fn, which is the same length as our Fg. Alright, then from there we might have an applied force, a frictional force, so on and so forth. Alright, so free body diagram, the arrows point away from the object. And their length is proportional to the magnitude. Okay, are we happy with these basics? Alright, any questions about the basics? Because this, if you get this right, you can get yourself 30%. Yeah.
And do you need an arrow indicating the direction of motion?
No. Alright, you don't need an arrow indicating the direction of motion. Alright, so if you can get this right, you've got 30% already. Okay. Alright, now we're going to see. Which question do you want to go through first? We've got inclined plane. Alright, we've got force at an angle, we have pulley.
Question 2. Pulley.
Question 2, the pulley.
Yeah.
Okay. So, one important thing when we talk about a pulley. What's important when we talk about a pulley? Alright, tension 1 is always equal to tension 2. Alright, the tension will be the same. So the tension on the string to the 5 kilogram will be the same as the tension on the string to the 20 kilogram. So there's one string, so tension will always be the same. Alright, so now let's look at our question. When we get a question like this, which is question 2 from the government paper February-March 2016. Alright, so let's read through it. A mass of 5 kilograms, we highlight it. Alright? When you get a question like this, we highlight it. It's a mass of 5 kilograms, highlight it. And a mass of 20 kilograms, highlighted, are connected by a light, inextensible string which passes over a light, frictionless pulley. Okay, there we go, frictionless pulley. Which means now we don't need to include the friction of that pulley. Okay, initially the 5 kilogram mass is held stationary on a horizontal surface while the 20 kilogram mass hangs vertically downwards 6 meters above the ground. So there we go, 6 meters above the ground, highlight it. The diagram is not drawn to scale. Okay, when the stationary 5 kilogram mass is released, the two masses begin to move. The coefficient of kinetic friction, so highlight that, is 0.4. Alright, ignore the effects of air friction. Okay, so now what we do is we write down what we have. Alright, we start our question by writing down what we have. We have, just from analyzing my question, I say 5 kg m is equal to 5. Alright, so I've got 5 kilogram box, we'll say 5 kg, and I've got 20 kg. Alright, and then I've got coefficient of kinetic friction being 0.4. Okay. So now we know a couple of things. We've learned a couple of things from this. Okay, so the first thing I do when I get this is I want to draw a free body diagram for myself. Okay, because that's going to help me with my equations. So I'm going to draw a free body diagram of the 20 kilogram block. Alright, so let's start with the 5 kilogram and then the 20. So in our 5 kilogram box, we have a force up, a force down. So this is our Fn, this is our Fg. We've got a force F friction, and we've got a bigger force F tension. Okay. So our force of friction is acting in the opposite direction of the motion, right? So that is why force of friction is going that way. Tension, all right, it can be Ft or you can just write it as T, will be going that way because that's the way it's being pulled. Okay, then we have our normal and our gravity which cancel out. Since the block is moving, my Ft is longer than that of Ff, force of friction. So tension is longer line than friction. All right, so now for the 20 kilogram block, we have force of tension and then a larger force of gravity. Alright, so do we have a normal force here? No, because we already have the F of tension and it's not on a surface, which means there's no normal force pushing up from the surface. Okay, there's only a normal force if it's pushing up from the surface. So now it says calculate the acceleration of the 20 kilogram mass. So I want you to note something important there. How many marks is it for?
5.
That means 2 equations. Okay. You get a 5-mark question, that means you need to use 2 equations. And this is the classic example. You will always calculate tension this way. So we have equation 1. Equation 1. F net is equal to MA. Alright, and then F net is equal to MA. So I'm doing this for the 5 kilogram block, this for the 20 kilogram block. Okay, so the 5 kilogram block, I'm going to have mine. So now I look at my diagram. So I have to decide which direction is positive, which direction is negative. So I'm going to say that way and downwards is positive, right? Because that's the way it's moving. All right, so I'm going to say for myself positive is that way and that way. Okay, so now I use my formula. I have F tension, so tension minus friction is equal to MA. You guys see that? Because tension is moving that way and I minus friction because that way is positive. So then I minus my friction, which is going that way. Okay? And then I have my second formula. So now down is positive, so Fg minus Ft is equal to Ma. Alright. So you guys happy with how I formed those two formulas there? Right, you're happy with why this one was a negative and why the tension here was a negative? Okay, now let's go change this to a T because that's what I use on the other side. Alright, so now let me start filling in my values. Alright, so let's go right paper. Alright, so let's calculate my frictional force. So I'm going to make a note over here and calculate my frictional force. So my formula for friction is UK times mg. So remember, F is equal to the coefficient of kinetic friction times Fn, right? You guys are aware of that formula? So let's plug it in. Equal to 0.4 times my mass, which is 5, times my gravity, which is 9.8. Alright, so I filled in those values over there. Alright, so that is my force of friction. So now I can either calculate it over here and get a value, or I can just plug that directly into here. May I please borrow someone's calculator? I do not have a calculator. Thank you. Alright, so it gives me an answer of 19.6. 19.6 what? Newtons, very good. So now I say tension minus 19.6 is equal to my mass, which is 5A. Alright, you happy with how I filled in these values? Alright, so here's my mass of 5 of the 5 kilogram box, because this is my equation for the 5 kilogram box, this is my equation for the 20 kilogram box. Alright, so I filled in my force of friction as 19.6, my tension I don't know, and then I've got 5A as my acceleration. So mass times acceleration, which is unknown. So now I have my Fg. So here that will be 20 times 9.8 minus tension is equal to 20A. Alright, so I filled in here, this is my mass, my force of gravity, which will make my Fg. My tension I don't know. And we have 20A, because it's 20 kilograms, and there's my acceleration. Alright, now put on your maths brains. Can you solve this for me? With your maths brains on, you can solve this using simultaneous equations, right? So what I'm going to do is I'm going to add the two equations together. Alright, because I've got a positive t and a negative t, so I'm going to say 20 times 9.8 minus 19.6. Let's put this here, tension minus 20.8 minus 19.6 minus tension is equal to 5A plus 20A. Because I've added the two together. Now my two tensions cancel. Alright, because I've got positive tension and a negative tension. You guys happy with how I'm doing this? Alright, so now I've got 20 times 9.8 minus 19.6 is equal to 25A. Alright? So, in case you're confused by which equation it comes from, I'm going to color my equations. Alright, this is my blue equation, there's my tension, and my 19,6, and my 5. And then here's my red equation, which gives me my 20, my other tension, and my that. Alright, so I just added them together. Yes?
Why didn't you also put a negative if on that other equation there was a negative in front of 20 times 1.8?
Okay, because there wasn't a negative here, I'm adding these two equations together. Alright, so it's, what we're doing is equation 1 plus equation 2. Alright, that's what we're doing here. Yeah.
Couldn't you just equate to, for example, say t is equal to 5a
Yeah.
plus 90, and then
Yes.
basically.
So you can make t the subject of the equation and then substitute t in. That's another way you can do it. Both ways are acceptable. This is just the way I do it. Alright, so we solve for A. Seven comma 0.056. Alright, and remember, is acceleration a scalar or a vector? Vector, which means it needs? Yeah.
Ma'am,
Yeah.
what if he said, oh, never mind.
Alright, so let's mark our question. So I get 1 mark for F is equal to MA. Alright, 1 mark for writing that. Nice easy mark. And then, let's see. 1 mark for this equation. 1 mark for this equation. That's 3. There we go. 1 mark for this. And 1 mark for your final answer.
And that formula there is to calculate friction.
Yes. Alright, so let's put this number in. This is 2.1.1. Let's do 2.1.2. Alright, any questions about this tension calculation? Alright, so the way we calculated this over here is how you will calculate it every time. If they ask you to calculate tension, we'll do it like this. Alright, so you first solve for A and then you substitute A back in and you solve for tension. That's how you calculate tension. Alright, if I ask you to solve acceleration if there's a tension, this is how you solve it. This is your recipe for solving anything if there's a string involved. Alright, if we have a string and tension, this is how you solve it. This is your 5 marks, done and dusted. Alright, it will always be a 5 mark question and this is how you answer it. This is your recipe. Any questions about your recipe for tension? All good. Do you want me to explain it again?
Yes, please.
Again. Alright. Just like curiosity, how many other people want me to explain it again? Okay. So, what we do is we first come up with our 2 equations. So this is our equation for our 5 kilogram box. And this is our equation for our 20 kilogram box. So we use our force diagrams to create our equations. So I say F net is equal to MA. That's the formula I get off of my formula sheet. Alright? From there I say tension, which is my positive, minus friction. Alright? Tension minus friction is equal to mass times acceleration, because the addition of my horizontal forces will be my net force. The way I add my horizontal forces together, that will create my net force. Okay? Then I calculate my frictional force, because this was F friction, so I need to calculate this frictional force. Alright. Here's my calculation for my frictional force. So, friction is up here. That's my F friction that I'm calculating. Right, so I calculate my F friction with my 0,4, which is my coefficient of kinetic friction, and then my mass of 5 and 9.8 is my gravity. Because that's my formula is UK times Fn, and Fn is my normal. Normal is calculated, mass times gravity. Okay, we get my answer of 19,6. Okay, that is my force of friction. So I add that into my equation. So now here I substitute my values into my equation. I know 19,6, I calculated my force of friction. I know my mass is 5 because this is my 5 kilogram block. Now we need this here. And we go on to our next formula. We write down our formula. F net is equal to ma because that's what we do off the formula sheet. Then we have our gravity, which is positive, minus our tension, which is negative. Because remember, we chose the direction positive as across and down. Right, that's the direction we chose as positive. So that means this is our positive value and that's our negative value. So we say Fg minus tension. Alright? My Fg is my mass times gravity. So there's my 20 times 9.8. Now minus my tension from it. Okay? It's equal to 20A. Alright, you guys happy? Alright, you guys understand how I got from there to my final answer? That part you understand? Okay. Yeah.
I'm confused on where you added the equations together. That's really not.
Alright, so there's a separate way to add the equation. So we'll call this option 1. Option 2. We make tension the subject of the equation. So tension is equal to 5A plus 19,6. This is equation 1. Equation 2. Alright, we say 20 times 9,8 minus, I've got my answer for tension here, 5A plus 19,6, alright, is equal to 20A. Alright, you got happy with how I did that? Alright, that makes a bit more sense. Alright, so this is the other way. I found the answer for tension, and then I substituted it into equation 2. Alright, this is your simultaneous equations for maths coming in. And then I solve for A, which will give me 20 times 9,8 minus 19,6 is equal to 25A, and I get A as 7,056. Alright, those are my 2 ways I can do simultaneous equations. 2.1.2, calculate the speed of the 20 kilogram mass as it strikes the ground. Right, so now we're talking about speed. Can I use F net is equal to ma? No. What must I use? Equations of motion. So, I have my, what is mine? The initial. V final is what I want to know. Acceleration is, we worked it out, 7,056. Alright, so now do I have enough to calculate? Oh, and I have my distance. What's my distance? 6. So it's delta y, not delta x, is equal to 6. Can I calculate my velocity final? Alright, so F squared is equal to VI squared plus 2A delta y. Do you guys understand why I use delta y, not delta x? Because it's vertical. Right, it goes in the vertical plane, not in the horizontal plane. X is horizontal like the x-axis, y is vertical like the y-axis. Alright, so I fill in my values. Df is what I want to know. 0 plus 2 times 7,056 times 6. And I get an answer of 9,2 meters per second. Alright, is velocity a scalar or a vector? Vector, which means I say down. Sorry? Yeah. Yeah, I just got the answer off the memo. So I think that's just got there. Alright, so now let's mark. 1 mark for this, 1 mark for correct substitution. And I think you get 2 marks for correct substitution. Yeah. 2 marks for correct substitution, 1 mark for your final answer. Alright, so now 2.1.3, we have our higher order question. So what do you guys know about your higher order questions? They make you think. You gotta think about them. You can't just answer them with a recipe like we did this. You actually got to think about your higher order question. So, at what minimum distance from the pulley should the 5 kilogram mass be placed initially so the 20 kilogram mass just strikes the ground? Alright. So, the 20 kilogram mass just strikes the ground. That means it doesn't strike the ground and then string pulls on top of it. Alright, it just strikes the ground. How long must this string over here be? 6. Because the amount that moves that way will be the same as the amount that moves down. So, 2.1.3, 6 meters. Alright, so that's our pulley question. Yeah.
The direction, the reason we said down because we're using the 20 kilogram.
Yes. Yeah. Because it says, calculate the speed of the 20 kilogram mass. Okay, can I rub this off? I would say, do you want to take a picture, but I'm recording it, so you can just look at the video I post later. Yeah.
But speed doesn't have direction.
What?
Speed doesn't have direction.
Doesn't it say calculate the velocity?
Yeah. Oh.
Oh, speed, yeah. Don't worry, you're not going to lose a mark for adding direction. Okay. Alright, so the next question we're going to do is question 4, an athlete in training. Alright, so next is the IB paper 2018. Alright, question 4. Alright, so an athlete trains by pushing a heavy box of mass A of mass 23 kilograms, which is in contact with an even heavier box B of mass 31 kilograms. across a rough surface of a field as shown in the diagram below. The athlete exerts a force of 134 newtons at an angle of 36 degrees to the horizontal box A. And each box experiences a frictional force of 45 newtons. Boxes accelerate horizontally. Okay, so now what you do is when you get a question like this, you highlight the things that are important. Okay, so that would be the mass of the two boxes. Alright, so the applied force, the frictional force, and the angle. Those would be our important points from this. So, question 1. Draw a label free body diagram for box A. Alright. 4.1. Label free body diagram for box A. Alright, so you see it is for 5 marks. That means there are 5 forces acting on it. Alright, so that's how you know how many forces there are, is because it's 5 marks. So I start. What will I always have? 2 easy marks. Yep. Oh, sorry, that's pretty skewed. Fn, Fg. Alright, so then I have my F applied. Okay? We'll get to that one just now. So I've got my F friction. And I have my F what? F friction and Fd on A. Alright, there's your Newton's third law. A lot of you have asked, oh, we only do Newton's second law, is that all that comes up? No, this is how they ask Newton's third law. So here's your Fb on A. Right, your F friction. And your Fb on A. So now, yeah.
And why is it longer than friction?
I don't know. I don't know which one is the bigger force. So I haven't calculated yet. So they can't mark you down if you make that one longer. Because I don't know which one's longer at this point. Okay. So now I have my applied force. Do I draw it like this? Alright, hands up for yes. Hands up for no. Very good.
Oh, okay.
That's an angle. Alright, that's my FA.
Friction. That's why it's like it goes there.
1, 2, 3, 4, 5. There's your 5 marks. Yeah.
Does it matter if you divided it into its x and y components?
Yeah, you shouldn't do that. Alright, you shouldn't divide it into its x and y components. That's for your vectors, not for your force. Yeah.
And do you have to draw the angle?
Let's see. No. Alright, you don't have to draw the angle. Okay. So there's a nice easy 5 marks. 4.2. Draw a label free body diagram of box B. Alright, so we see it's 4 marks, which means 4 forces. Fn, Fg, Fa on B, F friction. Alright, so now, this is 9 marks out of a 25 mark question. You've already got 40 marks for this, 40% for this question that you can draw your free body diagrams. Alright. And this is an IEB paper. It's not like this is easy because it's a government paper. This is your IEB paper. Okay. Then it says state Newton's second law. 50% of, almost 50% of your marks come from just your basic stuff, your free body diagram and your Newton's second law. So I'm not going to state Newton's second law again. That's something you have to memorize. 4.4. Use Newton's second law to write an equation in terms of the horizontal forces acting on box A. So now we use our free body diagram. That's how we write our forces acting on box A. So, I want my horizontal components. These are the components of the forces I want on my box A. So I start with F net is equal to MA. Right? Nice, easy first mark. Then I say, alright, my frictional forces, which side is going to be positive, which side is going to be negative? Positive, negative. Okay, so that means this side's positive, that side's negative. So I have FA. Can I just write FA like that, or do I need to do something else to it? I need to use my trig ratios. Alright, so we have our triangle with our angle, our opposite, adjacent, and hypotenuse. We have sine, cos, tan. Alright, so you guys remember your ratios. Alright, go soccer, toa. Alright, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is OA, opposite over adjacent. Alright, so now I look here. Here's my angle. Alright, I want my horizontal component of my hypotenuse. Do you see that? I have my hypotenuse. I want my horizontal component, and here's my angle. So it'll be adjacent. So it'll be cos 36. Alright, you guys see how I got my angles there? Alright, so use my trig ratios. Then I say minus force of friction minus, wait, I'm doing for box A, yeah, minus FB on A.
Now, what does FB on A mean?
Alright, so Newton's third law states that every force has an equal and opposite force. Alright, so if I'm pushing on this wall's pushing back on me. Alright, this is our basic stuff. I think we did this in grade 9. Which means, if I'm pushing this box along here, if I'm pushing this dustbin, even I'm moving it, the dustbin's still pushing back on me. So if these two boxes, box A is exerting a force onto box B, and box B is exerting a force onto box A. So by Newton's second law. Alright, so that's where force of B on A comes in. It's equal to our mass times acceleration. Alright. There's your 4 marks. 1, 2, 3, 4. Yeah.
You have to say if A equals 36.
Yes. You don't say if A cos 36, then it's not correct. Because we're looking at a horizontal and vertical component of this force. So here's our force, and here it is at this angle, right? This is our FA. So now it has a horizontal component and a vertical component. It won't apply I think it was 134 newtons, won't all be applied horizontally because it's at an angle. So here's our triangle, here's our 36. So we have to work out only the horizontal component.
And what if you just say if cos 36?
Yeah, f cos 36 is also fine. Okay. You have to say the cos 36 part though. Alright, so let's read our question. Alright. State Newton's third law. I'm not going to do that, you can learn your own definitions. Calculate the force that box B exerts onto box A. Alright, so now I want the force box B exerts onto box A. Alright, so I'm looking for this value over here. Okay. So, like with tension, alright, our forces will be the same. Alright, the force the object box B exerts onto box A will be the same as box A exerts onto box B. Right? Because every force is an equal and opposite reaction force. Okay. So I need my second formula. So this is 4.6 now. force box B exerts onto box A. So I start here. So this is my formula for A. I want my formula for B. Alright? Where's my diagram? Here's my diagram for B. So F net is equal to MA. I've got FA on B minus F friction is equal to MA. Alright, you guys happy with how I got these formulas? So now let me, would you like me to make one the subject of the equation, or can I add them together? Alright, hands up for add. Hands up for substitute. Cool, I'm going with add because I prefer that one and both are more or less equal. Okay, so now I have my two formulas. So you can see here, if I add them together, sorry, took a moment. So I have F cos 36. My two frictions cancel out. Do you see that? Alright? My FB on A cancel out with my FA on B, which gives me my two masses times acceleration. So before we do this, let's just pull in our values. So we have our equation B, and we have our FA on B minus 45 is equal to my mass, which was, box C has a mass of 31. Now let's do equation for box A. We have FA cos 36. Let's actually pull in our value for FA was 134. 134 cos 36 minus 45 minus FB on A is equal to 23. A. Right, you guys have to filled in those formulas. Now I'm going to add them to each other. So on this side we've got 134 cos 36. My FB on A cancels with my FA on B. Alright, equal and opposite forces. 45 cancel. Yeah. Oh, my 45 don't cancel, do they? Yeah. Alright, so that means I have minus 45 minus 45. Alright, so then I've got 31 is equal to 31 A plus 23 A. So now I can solve for A. Alright? A is 0.34. So now that I've got A, I can substitute it back into my equation. Over here. You guys see that? So now I say FA on B minus 45 is equal to 31 times 0.34, which gives me an answer of 55.56 newtons. So you see how this equation is the exact same thing we did with the tension one. We're following the same recipe every single time. So you see how there's only so many different ways you can ask the same thing in your exam. So the same question is going to come out in your exam. You guys see this, right? Yeah.
You should know another different reason. Why?
Yeah. Okay, you can ask just now. You got a different?
Yes and no. I got 5 and 9.
Oh. Okay. Yeah, that's fine. Yeah.
I want to ask, at that, at the previous question 4.4, yeah, 4.4, why didn't you fill in the mass? Because we know the mass of A.
So it asks me for the equation. Alright? But I can fill in the masses that I know. That's also fine.
So
And so I can fill in the values. You're not going to lose marks if you fill in the values that you know. Alright, but since it's asked for an equation, you don't necessarily need to. Alright, check this for recording. Yeah. Alright. Yeah.
I'm kind of confused. Because, like, it says, the force that B exerts on A, why are we calculating A on B?
Can someone else answer that question for me? Alright, so it's asking for the force B exerts on A, and we've calculated the force A exerts on B. Alright, so can someone explain to me why we can use this answer? They're the same because every force is an equal and opposite reaction force. So the forces are the same. So what I should do here is say F A on B equals F B on A equals 55,56 newtons. If I want to be really thorough, that's how I do it. Okay. Define frictional force due to a surface. I'm not going to define it. You guys need to learn your own definitions. Right. Now comes the meanest question I have seen in a long time. It took me a good 15 minutes to work out this question. Okay. This is your higher order question. Box A and box B are made of identical material, yet each box experiences the same frictional force. Use a suitable equation to help you explain why box A experiences the same magnitude of frictional force, even though box A has a smaller mass than box B. Alright, so what they're saying here is even though these two boxes have different masses, they experience the same frictional force. Alright, that doesn't make sense, right? Yeah, that's also what the conclusion I came to. Said no, it does not make sense. And I sat there and I argued about it because no, it does not make sense until I looked at my diagram. Is there a vertical component to my force on my diagram?
Yes.
Yes, which means that my normal force isn't only going to be my Fg. It's going to be my Fg plus my vertical component of my Fa. Alright, my force of gravity plus my vertical component of my applied force. Okay. Alright. So now, what I say here is, I say, hi, you're early for 12 one.
Yeah.
Yeah, I haven't finished with the, 11:30 group, but you can join. You can join. Yeah. Alright, so, I say, it says, use a suitable equation to help you explain why they experience the same force. So I say, they experience the same force because Fn, alright, so I'd rather say the normal force, on box A is made up of the weight and the vertical component of the applied force. And then it says with the help of use equation, so I say F K is equal to UK plus Fn, where Fn is equal to F applied sine 36 plus mg. Alright, there's my use of a suitable equation. Alright, so what I'm saying here is my normal force, Fn, is made up of my force that's going down. Because look here, I have a vertical component of that force and I have gravity. So there's two different forces acting downwards. Right, which makes my normal force greater than it would be if it was just my gravity. Alright. Yeah.
And couldn't you have said because there isn't much difference between the normal forces?
Alright, you can say because there isn't any difference between the normal forces, but I want you to say why. So, this answer says, I'll read you the answer, it says, box A experiences the same normal force as box B, even though the mass of box A and box is smaller than box B due to the vertical component of force F. So you have to include the vertical component of force F.
I included that in the formula.
Yeah, so you have to also include in your verbal answer, your description, your written answer. Okay, this is the hardest question you can possibly get.
Emma.
How do I know? Because I couldn't figure it out. That's how I know it's the hardest question. It took me a good 15 minutes to figure this out.
I don't understand.
Yeah.
I need to talk about 15 minutes. It's going to take 30. When I felt heart palpitation,
Yeah.
my heart was just like that. My heart is doing palpitation right now. It's going No, I know she said no, I asked her again because I was like, wait, what are your questions that you were to ask her? Okay, must tell me everything she said no and yes to. The what? Did you need to know that? His main I'm waiting for Mr. Miller's scope to come out. Yes. You know Mr. Miller? Remember he said that?
Oh, I sent you an hour.
Normal force.
No scopes are vague. Vague. But it's better than what we got in the college. I like Mr. Miller. Miss Bubble tells you the topic, and she moves on.
And then she come up with
I love it when you take chat. You
there's no way.
that one was way too detailed.
Last question, I'm going to be moving on.
That one, it was way too
Alright, question 4.2. Alright, this is on your separate piece of paper. Question 4.2, this comes from the IAB paper of last year, 2021 IAB paper, question 4.2. So, this is the third kind of question they can ask you, an inclined plane. Alright, so these are your three kinds of questions. Applied force at an angle. A classic question for applied force at an angle is a lawnmower. Alright, because you're pushing a lawnmower, and that is an applied force at an angle. Your pulling is a classic question that always comes up. And then finally, you have your inclined plane. Okay, so we're going to do your inclined plane. Alright. So, 4.2. Alright, you know the drill. What do we do first? Read the question, highlight what's important. Alright? A box of mass 10 kilograms is at rest on a slope. The angle of the slope is 15 degrees and the coefficient of static friction between the box and the surface is 0.6. Okay? So we've highlighted what's important there. Oh look, draw a free body diagram. Same, every time. Alright, you see how you can get 30% in these questions if you can just draw your free body diagram and know your definitions. So 4.2.1, that is our free body diagram. So here's our box. The free body diagram for our box is a little bit different. Why? Because it's on an inclined plane. So my FG goes like that. My normal force. Alright, remember my normal force will be perpendicular to my object. So my normal force goes like that. Or my FG will go down. Alright, normal force is an angle.
Ma'am,
Yeah.
shouldn't normal force be smaller than FG?
No.
But now, like,
It's not moving.
Divided into its components.
Yeah, you're right. Yeah. There we go. Alright, so then I have FG and then I also have F friction. Alright, also at an angle. F friction.
Ma'am,
Yeah.
but it's stationary.
Yes.
So it's FS now.
Yeah, but it's friction. I say F, the force of friction. F is the force of friction. Okay. Yeah.
The question is to be more.
1, 2, 3. Yeah.
If you were dividing your FG into your FG perpendicular and your FG parallel, would that be wrong?
Yeah. Because that's not how it is in the memo. Alright, so guys, I'm sure you know physics by now. Your definition, you might understand your definition perfectly, but if you don't put the correct definition in, then it's wrong. So, because it's not like that in the memo. It's sad, but it's true. Okay? Because that's just not how you do it.
And why are we doing it at angles? Because there's angles.
Yes, because it's on an inclined plane. So that is the direction of normal, that is the direction of friction. Alright guys, so then we have a definition. Learn your definitions. Once again, we already have out of this 5, 9, 10, 11, 19 mark question, we already have 5 marks. If we just know our definitions and know how to draw a free body diagram. Okay, is there someone standing outside? Hi. Running a little bit late. Yeah, can you sit there, back, just join someone? Alright, just come join, and then I'll start again. Alright. Calculate the magnitude of the maximum frictional force acting on the box. So this sounds confusing, right? Maximum frictional force. So we know how to calculate a frictional force, but we do know how to calculate the maximum frictional force. Yeah, I know, exactly. So we just ignore the word maximum.
For real?
For real. Okay. You see how Newton's second law is a lot easier than you give it credit for. Okay, so how do we calculate frictional force? This is 4.2.3. Calculating static friction, what's our formula? Fs is equal to Us times Fn. Right? You guys happy with that? So now I put in my values. So I know my coefficient of friction is 0.6. Alright, my F normal is my mass times gravity times my angle, which is cos what? Let's check. Yeah, cos 15. now I get an answer of 56.8 newtons. Alright, you guys happy? Nice easy question. State Newton's second law. Do you guys see how often Newton's second law comes up as a definition?
Yes.
And do you need direction?
No. So, but you're not going to lose marks if you put in direction. Alright, so I'm going to say up the slope.
And if you said north or west, is that fine?
No, because they don't tell you which is north, south, east, or west here. Right. Yeah. Yeah, so there's copies at the back. Yeah. Alright, so calculate the minimum force that would have to be applied to the box parallel to the slope to start the box sliding down the slope. Include the direction of the applied force in your answer. Alright. So now we start with our F net is equal to MA. So this is 4.2.5. F net is equal to MA. Alright? And then from there we fill in our values. Alright, so he's going to say there will be an F applied, which is what we want to calculate. Plus my F, let's check here. Plus my FG sine 15. Alright, FG sine 15 minus my F friction is equal to MA. Yeah.
How do you know it's going up the slope?
How do I know that my friction is up?
No, where you put the direction.
Because friction will be in the opposite direction of motion. Alright, so friction won't have any direction of motion here because it's not moving. Static friction doesn't have a direction.
Yeah, that's what I'm asking.
Yeah, static friction doesn't have a direction. Alright, minimum force that have to be applied to the box. So now we solve for FA. Alright, so FA. Alright, and what will the acceleration be if it's only just started moving? 0. Alright, so FA plus 10 times 9,8 times sine 15 minus 56,8 is equal to n, so that's 10 times 0. Alright, you guys happy with that? Alright, guys happy with how I got that? Then we have to just calculate our FA, which gives us an answer of 31.44 newtons down the slope. Alright, 31.44 newtons down the slope. Alright, the final question is, the angle of the slope is increased. At what angle will the box begin to slide without an external force applied to it? So once again, this is your higher order question. Alright, this is your most difficult question you can get from a diagram that looks like this. 4.2.6. Hi. Don't worry, I'll be done in like a few moments with these guys and then we'll start with you. Alright. So, I start with my friction. Alright, so I need to find out my static friction. My kinetic friction. Alright, so my formula goes F, G, parallel, so your vertical component, is equal to your U, F, N. And I fill it in. So now, my FG vertical component will be 10 times 9,8 times times sine theta. So I don't know what the angle is. That's what I'm trying to work out. and it will be equal to my force of friction because it will have just started moving. Alright, so it will be equal to my 0,4, which is my, 0,6, which is my coefficient of kinetic friction, times 10 times 9,8 times cos theta. Alright? Guys happy? How I got those equations? Now I solve for theta. So, my 10 and 9,8 I cancel out. So I have sine theta over 0,6 cos theta is equal to, sine theta over cos theta is equal to 0,6. Which gives me tan theta is equal to 0,6. Alright, which gives me theta as 30,96 degrees.
At what angle?